So I think you've been working on inequalities since like elementary school, right? When they first teach you about, sometimes some elementary schools will talk about like the alligator, and the big alligator side's got to face the bigger number, and so they're talking about things being smaller than or greater than something else. So what I need you to be able to be comfortable with is inequalities in multiple forms. For example, many of you are comfortable, or hopefully comfortable, with an inequality like that. That should also be represented on a number line. So because it's an x, it should be on the x-axis, right? So you would draw the x-axis, label 0, label the numbers -1 and +4 on your number line. And then on those numbers, you put either an open circle or a closed circle, depending on what type of inequality it is. So at the -1, we would put an open circle. Let's do it in a different color. Let's do yellow. Okay, an open circle because it does not include 1. And then the 4 would be a closed circle because it does include 4 because of the line underneath. And then you shade in between. So that would be how it would look on a number line. And then if you were asked to say that in English, like to describe what that means in English, it would be like this. Numbers between -1 and 4. When it says between, it does not mean including. So between just means numbers after -1 and before -4. So then if you want to include, then you would do a comma, and then you would say which one you would include. And so we are going to be including 4 as well. Okay, so numbers between -1 and 4, including 4. So an example like that. So that was starting with an inequality. Another way you can do that is on your number line, you could, instead of using a closed dot, you could also use what's called a bracket. So it could go like that. So that could also be a way that I would know what you meant by that if you use that bracket instead of the closed circle. On the other side, where there's the open circle, another way to do that would be, instead of using an open circle, you could use a soft parentheses like that, like a, okay, and I would also know what you meant by that if you decided to use a soft parentheses instead of a bracket. So either open and close circles or a bracket or a parenthesis, and I'll understand what you mean. Okay, another example. All right, maybe you'll be given the number line first and asked to write down what that means. So perhaps you'll be given a number line, it's the x-axis. You might be given this with a bracket on it, and then the shading going to the left. When shading goes to the left, that means it's less than, and so you would write that. And because it goes all the way to the arrow, it's not a between anymore. It's just an inequality where x is less than, because it's going to the left, or equal to, because of the bracket, the number 3. And then you would write that as all numbers or all real numbers less than 3, comma, including 3, because it's closed. So you should be able to do that. You might see a number line that looks like this. Let's just go for 0. And let's do a parentheses on that. And let's go off to the right. So this is not a between again. It's just a single inequality, and that's the greater than when you're going to the right. And so you would write it as x, because it's on the x-axis. greater than, but not including, because it's a soft parenthesis, 0. And so then you just describe that as all real numbers, oops, greater than 0. But you don't say the including part because it's a parenthesis. Okay, any questions on that? Oh, I know, another way to show you how to do this. Another way to write this is to say what the beginning and what the end of the number line is. So on this number line, what would you say is the beginning? 0. What would you say is the end if you had to give it an end? Infinity. So another way you could write that would be like this, 0, comma, infinity, where the beginning number comes first and the ending number comes second. And then you use the parenthesis to match the parenthesis on the number line. And then you also do a parenthesis on infinity, because you could never be equal to infinity. You would never have a bracket on infinity because it's not possible. This is my least favorite way to do it, because that also could mean something else in math. What does 0, comma something, like if it was 0, comma 4, what could that also mean? It could be a point on a graph. This is my least favorite way to do it, but if you write it in inequality, I'll know what you mean. But I usually tend to use the inequality sign, the symbol, instead of using that. But they both mean the same thing. All right, so what are we going to use inequalities for? Well, we're going to use it to continue solving problems with inequality symbols instead of with equal to signs. So something like this, 3 parentheses x plus 1 plus 2 less than or equal to 5x plus 6. So you're going to solve it the exact same way that you've been solving things. You just have to graph your answer at the end. That's the difference with an inequality, is that you don't have a single answer, you have a range of answers, and so your answer would come with an inequality. So we're going to start this one by distributing. So this is pretty basic math. We'll have 3x plus 3, then plus 2 less than or equal to 5x plus 6. Then you combine like terms. You'll get 3x plus 5 less than or equal to 5x plus 6. Okay, what should I do to both sides next as I'm trying to solve this and combine like terms? What do you see that I could do? You could subtract 3x or you could subtract 5x. Okay, I typically would want to go where the x is going to end up on the left side. That's easier for graphing. So I'm going to go with the subtracting of the 5x term first. So I'm going to subtract 5x. That'll give me negative 2x. I'm also at the same time going to subtract 5. That'll give me 1, and the inequality between them is still less than or equal to. What's the last step we do to solve that? Divide by what number? Divide by negative 2. Now, do you remember that something special happens in inequalities when you divide by a negative? Okay, good. The inequality direction switches around. And when you divide by negative 2, then you'll have negative 1/2. So switching the direction, anytime you divide or multiply, not add or subtract, but divide or multiply by a negative number, you're going to switch. And then you would accompany your answer with a number line. So don't just stop when you get the inequality, but also draw the number line as well. And so we're going to mark negative 1/2 on our number line. Because it's equal to, I'll put a closed circle, or you could put a bracket. Closed circle or bracket, doesn't matter. And it's greater than, so we'll be going off to the right for our answer. Okay, so that's the visual representation of your answer. And then the last one, and we're finished. Okay, here's an example of a between inequality. So if we have negative 3 less than the problem 2x plus 5 over 3, which is also less than or equal to the number 5. All right, so this kind of an inequality has a beginning and an end. It just doesn't have a beginning with an arrow. It has a beginning and an end. So we want to work towards getting the x that's in the middle by itself. The first thing we need to get rid of is the number 3. That's the denominator. And so what I'm going to do is take each part of my left and my middle and my right, all three sections, and multiply them all by 3. I can't cross multiply with inequalities, but I can multiply by 3. So I'm going to do times 3, times 3, times 3. In the center, the 3 reduces away. So the center is plain old 2x plus 5. Oops. On the left, I'm going to get -9, and on the right, I'm going to get 15. Whatever you decide to do, you have to do it to all three parts of an inequality, not just the left and the right side, but there's a middle side too. What's next? Subtract how much? Subtract 5. Okay, I want to take the 5 away. You always look at the middle. But then you got to do it on the left side and the right side also. So I'm going to subtract 5. I don't have to switch the signs because I'm subtracting. So I'll have -14 less than 2x less than or equal to 10. Y is what? Say it again, Michael. Oh, okay, are you sure? Yep, doing it to all three. All right, and then my last thing is I start in the middle and I divide by 2. Do I switch the signs here? Why? Not negative. All right, so I divide all three parts by that number. I end up with -7 less than x by itself now, which is less than or equal to 5. So this inequality as it's graphed is going to have a beginning and an end. It's one of those in-between ones. So 1, 2, 3, 4, 5, mark it out. 1, 2, 3, 4, 5, 6, -7, mark that out. You can use open and closed circles, or you may use brackets and parentheses, whatever is your preference. I prefer the open and closed circle. So open on the left, closed on the right because of the inequality, and then shaded in the center. And so this graph has a beginning and an end. Another way to write this would be to write it -7, 5, -7 being the beginning, 5 being the end, putting a parentheses at the -7 to show it's an open circle side, and a bracket on the 5 to show it's a closed circle side, and that would be fine too. That's acceptable. So either way, whatever your preference is. My preference is usually the inequality, but I won't mark you wrong if you do it the other way. It doesn't matter.